All right, welcome back to another video. Today looking at 7.2 writing equations to represent relationships in tables. Really long title, but today is a rather quick one. So for example, I have an input chart, and sometimes you'll see it with the rule in the middle, or you just have your input outputs, and then you have to find the rule. So for example, here, Jim earns $8 per hour walking dogs in his neighborhood. The table shows the relationship between the number of hours and the total amount of dollars for D. Write an equation or find the rule to determine that this to be true. So what we need to do is we have dollars earned, right? So D is equal to, and we have to go back into our problem. So we have here $8 an hour. This would be our independent variable or our constant. It will never change. So we put 8 and then let's say H. And so how we test this is we put each value and we solve. So 8 times 1 does in fact turn equal 8. So that's good. Now if we plug in H for 2, 2 times 8 gets us 16, and we see it there. If we do 3, 8 times 3, 24, boom, and 8 times 4, 32. So we know that the rule for this example would be D is equal to 8H, or 8 times H. So that's kind of what we're going to be working with today, and the last couple problems that we'll go over has a added step that we really need to take care of. So if you have word problems like this, I always recommend to my students to go through their cubes checklist. For those of you that may not know what cubes is, we need to circle all the numbers. We need to underline the question. We need to box keywords or phrases. And then E and S kind of changes from teacher to teacher. But for me is to evaluate or equation. Or actually not evaluate. It would be more of like come up with an equation or expression. And then S is solve, and then I tell them to double check as part of that solving. So that's kind of what we want to practice when we see word problems. So first one that we have up here, we have our table to the left, and they give us the equation. We just need to figure out which value we need to put in that blank box to prove that it's true. Well, if we are dealing with addition and we plug in G here, 4 plus what is going to get us 13? And here we see it's 9. We do the same thing. We're all double checking. So 5 plus 9 gets us 14. Those are good. 6 plus 9, that gets us 15. 7 plus 9 gets us 16. So we know that the value that we put in to complete the chart that represents the relationship between G and M is equal to G plus 9. With this one, really goes into your times tables. So if we have any number, right, and we plug in 7 for D, 7 times what is going to get us 63? And if we go 7 times 9, we get 63. If we now plug in 8 for D, 8 times what's going to get us 72? That gets us 9. So we already have 2 9s here. 9 times 9 gets us 81, and then 10 times 9 gets us 90. So we know that the value there is also 9. So now these are ones where we want to take a little bit more care into reading these, because they can be tricky. So the shower in Jim's apartment uses 10 liters of water per minute. So this right here is our constant. It will never change. And we need to look at our chart and we need to solve. Well, if we go from 6 to 60 and we use 10 liters of water, we'll have W is equal to 10 times W. And we can double check this by plugging in, not W, M. See, important to make sure you double check everything. So 10 times 6 gets us 60, boom. 10 times 7 gets us 70, 10 times 8, 80, 10 times 9, 90. So we know that our equation, W is equal to 10M. Very similar one where a pizzeria puts 3 basil leaves on each caprese pizza. So we have our chart, and what I like to do sometimes is to draw, kind of like a pizza. So for however many basil leaves, there's 3. Don't make fun of my my drawings. But anyways, B is equal to, and then there's 3 on every pizza. So we have, if we plug in here, we would have 3 because there are 3 on each pizza. And if we multiply it and we plug in, let's say 5 here, we would get 15. If we plug in 3 times 6, we would get 18, and so on and so forth. So we would end up with 3P. So what I like to do is draw a little, picture. Sometimes it helps out in the long run. So getting a little bit more complicated now, Ted started a stamp collection with 6 stamps. So at the beginning, he has 6 stamps, 5, 6, and then each month he adds another stamp to his collection. So after every month, he adds a new stamp. So we have to represent the relationship between M and S. So if we have M or S is equal to what number what number plus, all we are doing is we have S is equal to the letter M plus 6, because he adds, a sticker plus 6. The 6 is his starting point, so this will never change. And then now we can test this. 3 plus 6 does get us 9. 4 plus 6 does get us 10. 5 plus 6 gets us 11. And then 12 plus 6 gets us 12. So we know that S is equal to M plus 6. All right, so we'll go one more question, and then we'll conclude for this video. So a team of glass blowers make 2 vases per hour. So this is our constant. At the end of each workday, they recycle. So key word right here. Recycle means to get rid of. We're not including it at the end of the workday. Their least favorite 7 vases every day, depends on how you say it. So we have V is equal to, and we have our constant. We have 2H, 2 vases per hour, and then since we recycled, we lose 7. So we will always pick our 7 least favorite. And so we want to test this. We plug in 4 into H, we would have 8 minus 7, that does get us 1. And then if we plug in 5 times 2, we get 10. 10 minus 7 does get us 3. And if we continue down, 12 minus 7 does get us 5. And 14 minus 7 does get us 7. So our final equation, 2H minus 7. So that is writing equations to represent relationships in tables. Have a good one, and I'll see you in the next video.